Hi, my name is Ben Romano. I'm Android engineer at Snapchat, working on the client systems and performance team at Snap. And today I'm going to be talking about client tracing at scale, or how we bring tracing to all stages of the development process, from local development to performance automation, and lastly in production as well. So for those not familiar with Snapchat, Snapchat started back in 2011 as primarily a photo and video communication app. And since then, we've grown into an app with many different capabilities. So we have a maps page, our messaging features, our camera with all of its lenses and filters, our stories page for friends content and publisher content, and lastly, our spotlight page, which is user-generated content. And so as we've built out more and more of these experiences, we've run into scaling challenges. We have all of these really important features all competing for a really limited set of device resources. And ultimately, in 2018, we ran into a problem where we could no longer continue to scale and do feature development at the pace we're doing while still maintaining a high quality bar on performance and just general functionality. And so back in 2018, we decided we're going to rewrite the app from the ground up and put in a better architectural framework in place that allows us to do more modular feature development and at the same time increase the performance and quality of our app. And so this was a really big bet that we took, and fortunately it paid off. We saw drastic reductions in our performance metrics, or drastic improvements in our performance metrics, and a huge decrease in crashes. And so with that, we then wanted to make sure that, okay, we've did all this great work. We spent a year pausing feature development to focus on the platform and the quality and getting things in a good spot, that we didn't want to just continually over time kind of slide back to where we were before and have to do this initiative again. And so we focused on our attributed everything framework, which made sure that we were holding feature teams accountable and holding ourselves accountable at the platform level to make sure that our app is staying performant. And so we attributed performance metrics such as slow and frozen frames, our scroll performance, page load times, and battery metrics. So CPU, GPS, usage, camera. And for all these performance metrics, we track them on a per team basis and can go and see how they're trending over time and encourage teams to kind of focus more on these performance metrics when they're comparing against each other and seeing kind of where they stand. And so this has worked well for us, but there are some growing pains here. Our app continually grows more complex. We're adding more pages into our app. We have these deeper user journeys, and depending on how the user's interacting with the app, you may get into different states, and it's very hard to kind of reason about that just looking at these kind of higher level performance metrics. Secondly, our user base has just naturally grown more diverse over time. Every year there's a new version of Android, which can affect performance. There are very wide-ranging number of device models. And so even as we're continuing to address these performance problems, the ones that are remaining are increasingly more and more pathological. It's performance issues that only occur on these OEMs or on this device, and it becomes very challenging to actually go in and root cause these regressions. And so just reproducing regressions has increasingly become harder and harder for us as we've scaled up some of our performance initiatives. And part of the reason for this is that performance metrics only tell you which direction you're going in. We can now hold teams accountable and say, hey, your feature is worsening over time, but unfortunately we don't have more details on why that's the case. You need to go in and kind of root cause and figure out what exactly has changed, release over release. And so this is where kind of tracing comes in. Tracing starts to explain why exactly something is shifting in the way it is, and starts giving this kind of this observability or explainability into these performance metrics. And so for folks not familiar with tracing, tracing is the collection of discrete events on a consistent timeline. And it's kind of abstract, and what the kind of key point there is that now events can be correlated with each other on this consistent timeline. So now we're no longer just recording, here is Here is a page load time. We can now also correlate that with our memory usage, with our CPU usage, and understand how these different resources competing for each other ultimately affect the user's experience. And so here in this kind of diagram below, we can see we have kind of two key concepts here, counters and spans. With counters, we can record a value over time and start to track things like memory usage and maybe see, okay, we have a leak in our app, and that's causing memory usage to increase over time. And secondly, correlating that back to spans or kind of user journeys in the app. In this case, startup, which is then broken down by different sections. And with that, we have this observability into our app that we didn't have before with our kind of prior approach to performance metrics. And so today I'm going to be talking about kind of introduction to Android, tracing in Android. Next, some of the strategies that we use to get instrument to our app and provide more context. Next, how we scale up our trace collection in production and locally. And following that, how we do data analysis on this huge collection of traces that we have. And lastly, kind of talking about how we use traces as part of our performance automation and detecting regressions internally before they ship to end users. So starting off, for collecting traces, there's a tool called Perfetto, which was shipped on device starting in Android 10. It is two parts. There is an on-device component, which is a binary which you can use to go and collect these trace events. And secondly, there's a Perfetto website accompanying it where you can then go and attach your phone to your laptop and then record starting and stop of a trace session. And so this is what Perfetto's UI looks like. It's very overwhelming at first, but kind of show three kind of key areas. At the top, we can see some system level stats. We can see CPU frequency on a per core basis, so pretty nitty-gritty details. Next, in this kind of blue box, we can see for the Google Camera app on the Android device, we can look at a specific thread, in this case the render thread, and we can see the work that's happening over time. And lastly, in the bottom, in the red box, we can then go and look at directly what are those pieces of work or tasks that are running on that thread at a given time. And with all of this, we can really piece together like a clear picture of what exactly is our app doing when it's running. And so tracing is simple enough in Android. There is a AndroidX.tracing library, which supports counters and spans for in-app instrumentation. And within the spans, there's two types. There's synchronous spans, which is for work that's happening only on a singular thread, for example, on your main thread or a background thread. And there you can do something like if you're doing JSON parsing, you want to track how long that's taking. And secondly, there is async spans for tracking work that may span multiple threads. For example, if you click something on your UI thread, or click a UI element, and you want to do an upload, that may finish off with an upload on a background thread. And so you want to track that kind of user journey throughout the app. And lastly, there's counters for just recording values over time. And another thing to note is that when you are tracing, you should always make sure that your app is not debuggable. Debuggable significantly changes how the Android runtime behaves and will affect your performance readings. Secondly, you'll need to enable the profilable flag onto your app to ensure that the traces can be collected from your application. And so now that we have some of these kind of Android tooling for collecting traces, the next challenge we have is that how do we make traces meaningful? So at first, when you're looking at your app and tracing your app, there's no instrumentation there. And so we've kind of had this chicken and egg problem where there's no instrumentation in your app because developers aren't using traces, and developers aren't using traces because there's no instrumentation. And so we kind of thought about ways of how do we bootstrap up our tracing to make it more actionable. And so one of the ways that we've done this is through our attributed schedulers framework that we built. And we did this as part of our kind of performance metrics effort that we did back in 2019. And so how this works is that all work scheduled through RxJava needs to go through these attributed schedulers. All of the work has human readable names associated with it, and so then we can pinpoint that work back to feature teams. And so in this case, we're creating an attributed call site for our camera feature on the capture controller. From there, we can then go and request a scheduler that's attributed. And lastly, with an Rx chain, we can then go and use that scheduler to run some work. And all of that code in that runnable will now be wrapped in this traced call. And so we have these human readable names to provide context on our background threads. And so here's what that looks like in practice. Pairing some of our attributed schedulers with our some observability around their schedule queue length, we can now track, okay, here is all of this work happening on our background threads, and during this section in our app, we have this kind of backing up in our queue. And so maybe that indicates we're doing too much work. Maybe our background threads are getting blocked on I/O. There's some deadlocking behavior. And we have this observability now to actually correlate these two things together and go in and solve or root cause what the problem is there and put a fix in place. And so next, we also have system stats and state tracking. Some of this comes out of the box for free for Perfetto, and we've also added some of our own custom tracking. Kind of some of the key things that we look at are garbage collection. So looking at how the garbage collector is performing. Are we allocating too many small objects, which is then leading to a lot of blocking garbage collections, which will kind of pause the world and lead to user perceivable jank. Next, we have memory for tracking memory over time. Are we leaking memory and eventually our app out of memories, run into an out of memory issue. Next, looking at network, are we being mindful of users' bandwidth? Can we do things to reduce how many network requests we're firing? And next, CPU usage to provide some context on, for this given device, with its kind of number of cores it has, are we just doing too much work and leading into these bad thermal states for end users? And lastly, we have these system state metrics that come from the Android framework, which also gives us a signal on how the framework thinks our app is doing. And so this is things like memory state. There is this on-trim memory call that you can listen to, which will tell you if the OS thinks your app is under critical memory pressure, and maybe you need to reduce your memory footprint. Next is network reachability to provide context on this user is on Wi-Fi, on WAN, or they have no network connectivity at all, and may explain why things are taking longer than expected or not completing. And lastly, things like GPS state, camera state, and thermals to provide context on if your device is thermal throttling, for example, that's going to have negative impact on UI performance as the OS is actively throttling the CPU. And next, we have our UI metrics instrumentation, and we have a couple of different frameworks internally that we built out, which allows us to add annotations around what is the current page that we're on by reporting a metric or a span in our navigation framework. Secondly, we have our page load latency framework, which on each of our page transitions records the start and stop of when the page transition started and then the time to interactive. And so this gives these metrics, it's very clear metrics on, okay, how is that user interaction? And lastly, we pair this with jank metrics, which jank is having multiple consecutive frames that are taking greater than 16 milliseconds to render, and that leads to user inputs not being received properly and leads to a bad user experience. There is a library called jankstats, which helps bootstrap creating this kind of jank metric, so I highly recommend checking that out. And so with all of these different UI metrics, we now have this really clear picture on what exactly is happening on the user's device and their user experience, and then tying that back to the main thread and trying to see how we can improve that experience. Digging a bit deeper into our page load latency framework, we provide these callbacks for feature teams to provide and say, this is when the start and stop my page is. Here are some subsections of that page transition. For example, you may want to track the time it takes to initialize your dependencies, do Dagger injection, the time it takes to load your data from the database, and lastly, the time it takes to create your view models and then ultimately render that. And so now this gives feature teams more clarity on what exactly are the sub-steps that are taking too long and how can we start to optimize that. Instead of just providing, like, here is this number which says your page load is 3 seconds, go and try to figure out how to optimize that. And so now that we have all of this instrumentation in place, we make it really simple for developers to do tracing by providing CLI tooling for teams. And so the reason we build these CLI tooling is if you can make it easier to do tracing, that will lead to more people collecting traces and encourage teams to add more and more instrumentation into their features. And the two flows that we provide are Ghost Trace Start, which we use for recording a trace, and secondly, Ghost Trace Action, which enables collecting a trace over a performance test. And we highly encourage teams internally to kind of use a second flow because this now gives you reproducible analysis over key user journeys in the app. And icing on the cake here is that if you trace through our CLI tooling, we'll give you a shareable URL, and now we can kind of spread awareness of our performance tooling and encourage developers to talk more and more about performance internally. And so one thing to note here is that tracing is only partial observability. So even if you add a lot of instrumentation, you're not going to find all of the performance problems. You may not have the right instrumentation in place, and you may need to defer to other tooling, such as Android Studio's Profiler, to go and actually root cause the issue. But at least tracing helps point you in the right direction of where do you need to start looking at to start optimizing things. And so that's something that we'd be mindful as performance engineers, that we're not just chasing after the problems that we can see and making sure we're taking kind of a holistic view of our app. And so kind of the next point here is that tracing locally can only solve problems that you can reproduce locally. And so this is one of the challenges that we face in that our user base is so diverse. There are users all over the world on different devices, different OS versions, and it's just not feasible for us to go in and run through all these different flows and all these different scenarios. And so one of the things that we started to look into is how can we collect these traces in production and kind of build more empathy around our users' experiences in the app and start to root cause these really pathological cases or P99 scenarios. And so this kind of brings the next section of the talk around scaling up collection. How do we collect traces in production? And so when we were thinking about production tracing last year, we started this project. Some of the things we need to make sure that we were accounting for is that tracing needs to be low overhead. Instrumentation should not affect the user experience at all, or as minimally as possible. And when tracing is not running, our tracing code is adding no overhead to users. Secondly, we need to be mindful of the file size. We really want to see what the user's experience is like on when they have low connectivity or poor connectivity. And keeping the file size small makes sure that we have higher guarantees or higher odds of actually getting those traces back from those users. And secondly, it's nice to be mindful of our users' bandwidth. And lastly, the kind of key point is that we need a mechanism that can be controlled by our app. Our application can say, this is when we want to start a session, this is when we want to stop a session. And so we initially tried to look at Perfetto and seeing, can Perfetto solve like these problems for us? And for low overhead, Perfetto is extremely efficient. It is specifically optimized for high throughput writing of trace data. And so it checks that box. But unfortunately, for the file size, since it primarily optimizes for write throughput and not size, these files can get very, very large. And so that was unfortunately a limiting factor for us. But kind of the nail in the coffin right now is around app controllability. We need to be able to control this lifecycle from our application. And unfortunately, Perfetto right now can only be triggered directly through ADB shell. And so that was kind of a non-starter for using Perfetto for tracing in production. And so we needed to find a new way to kind of collect this tracing data in production. And so this is where we started to develop our internal in-house lightweight tracing library, Trace SDK. So the key features of Trace SDK is that it can run in process and our application can control the trace lifecycle. Secondly, we've designed a new trace format which is intentionally designed to be as small as possible. And so now we can collect traces where it's about 130 kilobytes per minute, and we get very high compression rates on this data, and so we can capture longer sessions than we could with Perfetto in its file size, and additionally be very, very mindful of users' bandwidth. And lastly, one of the nice things with our tracing library is now that we can support new arbitrary data types. And so our tracing internally also includes network events and network tracing, and so there's another kind of piece of observability that we get through this tooling. And so the APIs are relatively simple of just start, stop, and cancel. With that said, since we are now in application, we do lose some of the benefits of Perfetto. Specifically, we can't see kind of more system-level stats. We can't see binder transactions, things like thread states. That's kind of the trade-off we need to make for production-level tracing. And due to those limitations, we don't just depend on our production tracing library for tracing everywhere. Locally, it makes a lot more sense to use Perfetto because we do want to see these like system level metrics and maybe look at other processes running on the device. For example, we're a very camera heavy app and we want to look at what the camera process is doing on device and kind of correlate that with things that are going on in our application. And so to support this, we've added a shim layer on top of Android X tracing. We call it Snap Trace Compat, which enables us to decide which buffers we want to use when writing trace data and using the best option depending on the context. And even though we've had to kind of replace Perfetto on the client side, that doesn't mean we need to give up all of the great tooling that the Perfetto team has built. Perfetto is pretty extensible, and so we've added in our own custom parser into Perfetto that enables us to use our snap trace format with the Perfetto UI and all the existing tooling. And it's very minimal amount of code, and we get to leverage this very powerful ecosystem of performance tooling. And so putting that all together, now with our Trace SDK, we can have all of our internal employee sessions now traced. And the nice thing about this is that every time somebody reports a bug internally, we now have an associated trace with it, and we can say, okay, this is why your user experience was bad, and now we can go in and solve that problem directly. Secondly, in production, since we have so many users, we don't want to be tracing every single session. We do a very, very small sample, and we collect traces from production. And now we have this kind of, within our local environment, we have our CLI tooling and internal builds. We have tracing on all sessions, and then production tracing that's sampled. And all of that goes through the same pipeline and can use our Perfetto UI, and we all store those traces together. And now that we have this kind of mass collection of traces, we provide a trace dashboard on top of that, which lets developers internally go and quickly find some of their past user sessions, and they can go and see the traces associated with that and see, okay, this is why exactly I had this bad experience. And it makes it easier for developers to go in and root cause these issues before they go to production. So with all of this traces that we're collecting, we now have this next challenge of how do you start to make sense of all of these traces that we have? We are generally, when you're locally tracing, you're opening up the trace file and manually clicking through things and visualizing it. But that's very, very tedious. And so kind of this other question we have is, which traces are even worth looking at? Is this trace going to actually surface problems that I'm interested in? If I'm on the camera team, I want to find traces where the user went to the camera page and had a really poor experience. There was dropped frames, frozen frames, and start to kind of figure out how we can optimize that experience. And so the goal here is that we want to be able to index the traces that we're collecting by the different features or functionalities that we see within the trace. And so we call this process, this process is indexing traces, and what we're doing is extracting features, which is developer-defined properties of a trace, extracting those out, indexing them, and then using that to go and help find these traces with these different scenarios. And so some of the examples of features that we have is the startup types that we have. Was there even a startup at all in this trace? Is there jank? How much jank was there? The set of pages that were viewed. And secondly, not only are these kind of just features or properties of the trace, we can also create new metrics off of these. So we have our page load framework that we talked about, and now we can take those spans that we've generated and build latency metrics from them and start tracking the latencies from the traces that we've generated. And so now we have latency metrics, performance metrics, which have this backing visualization or kind of more detailed view that gives us the context on how these two things relate to each other. And so how do we actually go about extracting some of these useful things from the traces? Interestingly, Perfetto internally models traces as a SQL database. And so what that means is that we can query against the traces just with SQL and run a SQL query and say, find me this span with this name and extract out the duration of it. And this SQL engine also supports outputting the data in arbitrary formats, and so we can output metrics from this as well. And so here in the screenshot, we can see there is, trace comes in, it gets converted into this in-memory columnar database, and below we can see here is a set of tables that get generated, and then you can go and query against and do joins against those. And so with all of this tooling, we now can extract things like our page load times, as mentioned before. And here we can see what was the overall load time, how long did it take to get to the data loading portion, how long was it creating the view models, and we can get this kind of really detailed analysis on the large set of traces that we have, and then go in and pick those ones and kind of dig a bit deeper into what exactly happened in that scenario. And so this is what kind of our pipeline looks like, where we have the traces coming in. Developers can write these Perfetto or SQL queries and use that to extract features out, and then we store those features for indexing purposes. And so now that we have all these features indexed, we can create trace dashboards where developers can go in and ask for a trace where they have certain scenarios. For example, I want to find the trace from Android 10. The user went to the camera page, and when they were transitioning to the camera page, it took greater than 3 seconds to load, which is way too long if you want to capture the moment. And secondly, you may want to say, okay, I want to find a trace where the CPU was constantly at 100%, and that's causing some thermal throttling according to the system. And we can go and see, okay, here's the scenarios where our app is kind of not performing well and leading to the device to get into a degraded state. How can we now go and address those performance problems? And so this is the way that we now go in and kind of make sense of this huge, massive traces we have, and then we can decide what do we want to drill down on more and more and get more insights into. And so fortunately, you don't have to go in and build out these features yourself. Perfetto out of the box already supports some of these kind of trace-based metrics. And so if you go to the Perfetto UI, load your trace, go to the metrics tab, you can then go and do some analysis, for example, for startup, and then get a kind of an overview or deep dive into your startup's performance, all the kind of relevant sections there. And so this is just an example of one of them. There's many more of these, and new trace-based metrics are being built into Perfetto to help provide more and more context into your traces. And so now that we have this kind of indexing capabilities, there's still an ongoing challenge of, it's great that we found a trace that represents some user flow, it's surfacing all these performance problems, but is that problem actually representative of a widespread issue? Did we just happen to stumble upon an issue that occurs 1 in a million, 1 in a billion, or is this something that's happening 1 out of 5 sessions, and we need to go and solve this performance problem immediately? And so kind of the next phase for us is figuring out how we can do more kind of root cause analysis and automating some of the detection process of these kind of pathological cases and performance issues. So next, I want to talk about performance test automation. How do we leverage tracing and performance tests? And one of the things that we use, we have our own performance test framework, which has tracing baked in directly into the framework. If anyone's using macro benchmark, this is exactly the same thing. We built some of these tools before that was open sourced or released, but the premise is very much the same, and highly recommend using macro benchmarking for your performance testing purposes. So the kind of key points here is that we can define, we want to run 30 iterations of a performance test. In this case, it's our cold startup performance test. Between each iteration, we kill the app, and then we have this measure block, which is the actual portion we want to go in and analyze more deeply. And so this is opening up to our camera page. And during that measure block, we collect a trace each time, and we can take those traces, use some of the feature extraction processes that we built, and then go extract metrics from those traces. And so leveraging on top of our performance testing and the traces that we're generating per iteration, we can now then feed this into our performance testing automation tools. And so developers internally can provide 2 commits, a performance test that they want to run. We'll run 30 300 iterations on some base commit, on a test commit, collect all those traces, analyze the metrics, and then report the differences in key performance metrics. And so now developers have this very easy way to get reliable, statistically significant performance metrics on the changes that they're making. And this significantly reduces the turnaround time, whereas before you have to run A/B experiments and maybe wait a week or two and find out, oh, I have this bug, which actually leads to performance being worse. And so this is a huge time save for developers internally as they're doing performance work. Secondly, to make this flow very easy for developers, we have Git webhooks internally. And so as they're doing feature development, they can run a command to go and say, run the startup performance tests. And on the PR itself, we'll add some comments saying, here's the regressions that we found or the improvements that we found. And so continuing to lower the bar to do performance testing and performance work ensures or increases the developer adoption of tooling and thinking about these problems as their kind of general day-to-day development process. Next, now that we have the capabilities to do extracting these metrics from traces, comparing them commit over commit, we can now start to track these performance metrics over time as code is merged into our main branch. And so in this case, we're looking at our startup performance test. We're tracking the startup latency, and we can go and see, in this case, there's no regressions, which is good, but there may be cases where there's a step function increase in the latency, and then we can go and pinpoint kind of the commit that led to that issue. And so this drastically reduces the kind of time taken for investigations and kind of trying to figure out why is my performance metric in production regressing. Here's this latency number that's changed. I don't know what kind of the next steps are to do. In this case, it just reduces all of that overhead and starts to streamline the development process. And so kind of the key takeaways here is that as you're building more performance metrics and performance instrumentation, you want to make sure that you're providing the right set of tools to developers to not increase overhead as teams are doing feature development. You should increase the quality bar while keeping velocity kind of around the same pace. And so ultimately, performance testing with tracing allows us to iterate much more quickly and spend less time root-causing issues. And so with that kind of wrapping up, there's kind of a couple of different things we talked about. So first off, like the introduction to how tracing in Android works and some of the existing open source tools that are provided out of the box. Some of the frameworks that we built internally to provide more context into our application's performance through our page load frameworks, our navigation frameworks. And secondly, the trace SDK that we've built to then go and collect these metrics or these spans in local development environment, internally, in our performance automation, and lastly, in production as well. And how we make sense of those traces through our feature extraction process and enabling developers to go and define relevant aspects of a traces, and lastly, surfacing that through different reporting mechanisms, whether that's through visualizing in Perfetto's UI, going into our trace dashboarding tool to help find these certain scenarios or user journeys, and lastly, within our performance tests to make sure that we can catch regressions before they go into a production. And with that, are there any questions?